Lenz's law is used to figure out the direction of the current that is flowing when you make a change in magnetic flux and induce an EMF. So suppose there is a change in magnetic flux and that induces an EMF. Then you're going to make a current which will be created or induced in this loop or coil of wire that you have. The new current that's made has to make a new magnetic field. And that magnetic field has to oppose the change in magnetic flux. Now we have to emphasize here that we're not necessarily saying that we're opposing the new magnetic field. We are not saying that the new magnetic field is necessarily in the opposite direction of the magnetic field that was making the magnetic flux. That can happen, but that's not directly what Lenz's law is telling you is happening in each case. The idea here is that you are now creating a new current in a loop. That current has to make a magnetic field. Can that magnetic field be made so that this process feeds back on itself and creates infinite amounts of current? No. There has to be something which is fighting to retain the balance of energy. So the new magnetic field is going to be made to try to oppose the changes that are happening in flux. Your job using Lenz's law is to learn how to figure out what exactly is going on in this situation which is making the flux change, and how do we oppose that change. So these are the questions you should be asking when you're using Lenz's law. First of all, what is changing in order to make a change in flux? Is it a change in magnetic field strength that's creating the change in flux? Is there a change in the amount of area that we're talking about to change the flux? Is there a change between the angle of the magnetic field and the direction of the area so that the angle between them is changing, because that would also change the flux? So once you figure out what is changing, you should be able to identify how is the flux changing. Simply figure out, is the flux increasing or decreasing in this situation? Then you know how much or what the kind of change is. Now you should be able to figure out what opposes that change. For example, an increase opposes a decrease. If you have a decreasing amount of flux, then you want to oppose that with an increasing amount of newly made flux. So, once you know how you need to oppose the change, you ask yourself, what would the direction of the new magnetic field need to be in order to oppose that change that I was talking about up there? How do I get a decrease in flux by making a new magnetic field? Well, as an example here, to increase the amount of magnetic flux, your new magnetic field would point in the same direction as the original magnetic field that was causing the flux. So, if you had a situation where there was a decrease in flux and you wanted to oppose that with an increase, your new magnetic field actually points in the same direction as your original magnetic field, according to Lenz's law. Now, this will tell you which direction the new magnetic field has to point. The final step then to determine the direction of the current is, ask yourself, what direction does the current need to go in order to make that new magnetic field that I figured out up here? You would use that new right-hand rule that we were talking about, where you point your fingers in the direction of the current, and then that tells you the direction of the magnetic field. Only you'll use it in reverse. You know which way your magnetic field has to point. That tells you which way the current has to flow. And we would typically report this as being clockwise or counterclockwise when you figure it out.